All right, guys, today we are going to talk about the multiplication properties of exponents. Um, and before we do that, I just want to review a little bit of vocab that you know about sort of exponents. So we know the exponent is the number in the upper right-hand corner. The number that's below it is the base. So if I'm kind of looking here, that's the base. And the whole thing we kind of call a power. And we know if we write that out in expanded form, it looks like over here, the base times itself, however many times the exponent lists there. So that's a little bit of review of what you know. What we're going to do today is actually add in ways that we can sort of combine or put together now problems that have more than one power or more than one set of bases and exponents. So in the middle of your screen here, I can just enlarge it, you have the three properties. It is not important to know the names of these properties at all. So one of the things I want to highlight here is that you're not going to hear me emphasize the names of these properties a lot. They have names there kind of telling us what they are, but the big thing is what you do. So the first one, when you have the product of powers, it means when you're multiplying two things with the same base, you add the exponent. So you can see two examples here, right? When you're multiplying 3 to the 4th times 3 to the 3rd, same base, add the exponents. When you have the power of a power, the one in the middle there, right? So when you have one exponent sort of next to the other, you multiply those exponents. So you can see your example, 5 squared all to the 4th becomes 5 to the 2 times 4. You multiply the exponents, or 5 to the 8th. And then the last one is what happens when you have the power of a product. So the exponents outside a set of parentheses. And what you do there is you essentially kind of just distribute the exponent to each of the parts inside. Right. So what we're going to do, the best way to kind of learn these and get good at these rules or properties is to practice them. So you're going to see quite a few examples I'm going to do with you down below. Right. At any point during the video, if you're starting to feel comfortable, I think a great idea would be to pause the video and try the next example. So if we do the first 3 or 4 and you're thinking like, I feel pretty good, let me try the next 1 or 2, pause the video, try it, and then see if you got it correct and listen to my explanation. Okay? So the first one there, we're multiplying. These two things have the same base. They both have a base of 5. So we keep the base the same and we add the exponent. So we get 5 to the 9th. And you can simplify that if you put that in your calculator. You would get a very large number. It is 1,953,125. All right, and you could just keep it as 5 to the 9th, or you could write it as its number form. For the second one, here's an example of a power of a power. So you have two exponents next to each other. So we know that we keep the base the same, and then you multiply the exponent. So 5 times 2 is 3 to the 10th. Again, I could write that out as a number, be 59,049. But again, leaving it as 3 to the 10th would work as well. The third example we have is now that third rule, which is the power of a product. So we have in the parentheses, it's really like saying 5 times x times y to the 6th. We don't often read it like that. We just would say 5x y to the 6th. But what really has to happen is that exponent has to go sort of each part. So we're going to have 5 to the 4th, x to the 4th, and then y to the 6th to the 4th. Now, this is not my final answer. I'm going to keep simplifying. So 5 to the 4 is going to be 625. And I have x to the 4th. And here now, and this is where the examples start to get a little fun, we have another one of our rules. Right? So when we distribute that exponent, we now have the power of power, so we're going to multiply. So that will give us y to the 24th. And there's my final answer, 625 x to the 4th, y to the 24th. Notice that we cannot combine the x to the 4th and the y to the 24th because they have different bases, right? So again, different bases here, we can't combine anymore. So my final answer is just 625 x to the 4th, y to the 24th. In number 4, and this is just your basic power of a power, we bring in its variables. So we multiply, we're going to have y to the 12th. You can simplify that to a number because y is just a variable. In number 5, right, so here we have now we're bringing in some numbers and variables. What I'm going to do is I'm going to start, right, by just focusing on the numbers, the -7 and the 8. Now, one of the things that you would hear me say if we were in class is that what's the operation? The operation in between them we know is just multiplication. That's what those two parentheses next to each other mean. So when I'm dealing with regular old numbers, I just follow the operation. So -7 times 8 is -56. Now, the other part I have to deal with here is the variables, the b to the third and the b to the ninth. Well, I know that when I'm multiplying two things with the same base, I keep the base the same and I add the exponents. So my final answer here for this one is -56b to the 12th. All right. Again, I don't distribute. Notice it doesn't look like this. If it was -7b to the third, then I would distribute that exponent. But that's not what we have. The exponent of 3 is only on the b, so it doesn't get distributed. Mhm. Another way of thinking about this problem, and you'll see it if you actually compare it to number 9 right below, I could also have written the same problem without the parentheses, just -7b to the third, then just the multiplication symbol, and then 8b to the ninth. I would have simplified the same way. Number 6. So here's actually kind of a basic one, but I wanted to show you that you can do this with like 3 terms, bring in more terms here. We have n squared times n to the 5th times n to the 4th. They all have the same base, so I'm going to keep the base the same, and then I add the exponents. So 2 plus 5 plus 4 is 11. So n to the 11th. Right? Number 3, you'll notice the exponent is outside the set of parentheses, so it's going to get distributed to each part. So I'm going to have 4 to the third, y squared to the third, and z to the third. And now I just want to go through and simplify. So 4 to the third is 64. Y squared to the third. Here again, we have one of our other properties. It's the power of a power. We know when we have the power of a power, we multiply. So it's, whoop, my bad. Let me switch back. Y to the sixth, and then z to the third. Again, we can't combine these. I can make a note here. Right? Can't combine the different bases. Different bases. Right? In example 8, again, we have an exponent outside the parentheses, so I'm going to start by distributing it. So I'm going to have 5 to the 4th, a squared to the 4th, b to the 7th to the 4th. And then I simplify, so 5 to the 4th is 625. A squared to the 4th, again, you've got a power of a power there. When they're right next to each other, we know that you multiply, so it's a to the 8th, and then b to the 20th. Same thing as here, we can't combine the A and the B because they have different bases. Right? As you start getting good at these type of examples, and you'll see it in number 10, I might do it this way. I can actually, instead of writing out that middle step, do that part in my head. So you'll notice that I may start to do that. Right? In number 9, right, I'm going to go ahead and combine. So I'm going to have, right, 4x to the 7th, y squared times 5x to the 3rd, y to the 4th. Right? So I'm going to start just with the numbers, the 4 and the 5. What's the operation? The operation is multiplication. So 4 times 5 is 20. Then I'm going to look at the things with the common basis. So I have an x to the 7th, x to the 3rd. When we multiply with the same base, we add the exponents. So that's going to be x to the 10th. And then I have y squared times y to the 4th. When you're multiplying with the same base, you add the exponents. 2 plus 4 is 6. And there's my answer. On my final example here, I'm going to take out that middle step. So I'm going to start on this last one. This is the hardest one. 3 to the 3rd is 27. X squared to the 3rd, that's a power of a power. So I multiply those, I get x to the 6th. And then power of a power when I distribute to y to the 3rd, y to the 9th. You'll notice the middle term does not have a power around it, so I'm going to keep that the same. That's really like saying negative 2 times itself 4 times. That's going to give me a positive 16. Then I'm going to have x to the 12, y to the 4th. And then my final step is just to look at everything that is sort of like common terms. So I'll start with the numbers. 27, 5, and 16. The operation is multiplication. So when I multiply 27 times 5 times 16, I get 2,160. Then I'm going to look at the x's next. When I'm multiplying with the same base, I keep the base the same, I add the exponents. So 6 plus 5 plus 12 is 23. And then the same thing with the y's. Y to the ninth, y to the fifth, y to the fourth. When I'm multiplying with the same base, I add the exponents. So I get y to the 18. And that is my final answer. Right? So as a summary there, when you're using your properties of exponents, right? Product of a power, multiplying with the same base, add them. When it's a power of a power, they're right next to each other, you multiply. And when you have an exponent on a set of parentheses, you distribute it to each part and then simplify.